Hello, everyone. This is section 2.3 covering analyzing graphs, where we'll discuss what are some potential errors that exist in graphs and how can we go about rectifying them? What do they look like? And also, what do some distributions look like? So let's go ahead and start by an example provided from the text. Let's suppose that we are given this time series data graph here, which is simply a graph representing data over time. This is the federal hourly minimum wage rates unadjusted. Now, we are asked, what are some potential issues with this graph and how could they be fixed? So taking a look here, the first thing you should do when you're looking at a graph and you potentially want to look for errors is look at the scales. So looking my vertical scale, everything seems fine. Everything is nice and uniform. Gap of 1 for all of these. Let's look here. It seems to be 24th of October here. And then, oh, looks like I went 1 year and then 6 years and then 5 years and then 6 years, then 5 years, then 2 years, then 4 years, and 1. My scale is totally messed up. I'm going to need to reshape this with a properly pruned graph with a nice consistent X scale. So for this here, what I'm going to do is I'm going to take these data and rewrite it with a scale of, say, every 5 years on January 1st. When I do that, my graph now looks like this, where I see a little bit of variation and a nice consistent scale throughout. My data looks much, much better. And this is a much easier graph to analyze because it's uniform, it's consistent. There are none of those data errors that might lead one to erroneous conclusions. Okay. Now let's talk about some properties of distributions and what they might look like. So for this, let's just take a look at some definitions here. The graph's shape is uniform if the frequency of each class is relatively the same. The graph's shape is symmetric if a vertical line drawn through the center of the graph mirrors the image or would give mirror images on either side. The graph's data is skewed to the right when the majority of the data fall on the left. So when it's referring to skewed to the right, it has what's called a long right tail. So for example, it might look like this. We say the graph is skewed to the right because its tail over on the right side is long. Similarly, it's skewed to the left if you have a longer left tail and most of your data is on the right. So this is right skew. This is left skew. And an outlier is something that falls outside of the shape of this distribution. Okay. So let's take a look at some distributions and see if we can determine what are the shape of them. So let's start with this one here, for example. What type of distribution is this here? Well, if I take a look, it appears as though my distribution is symmetric about this here. This is a symmetric distribution. If I were to construct a curve looking like this, it would be the same from one side to the other. This is a symmetric distribution. Okay. A uniform distribution would look approximately, when I draw my distribution, it might look something like this here, where my data are basically the same throughout. You can have a little bit of variation, but approximately we see that be the same way. And my right skew and my left skew are when my data skew toward one side or the other. Okay. But this is a relatively short section, and this is all I wanted to cover for this section. If you have any questions or want to see more examples, please let me know. Otherwise, I will see you in the next video.